Okay, our numbers are starting to steady out, so I'm going to go ahead and get started. Hi, my name is Lisa Weaver-Moon. I'm with Ohio Concrete, and on behalf of myself, a promotion director, and the other promotion directors, Wayne Minning and Bob Krulik and Joe Vogel, and our president and executive director, Greg Colvin, we'd like to welcome you to our 6th webinar for our fall engineering concrete series. If you have questions during this presentation, we ask that you put them down below in the Q&A section. Do not use the chat button. Use the Q&A, please, for questions. And Dean should be able to hang on as long as needed to answer those questions. If not, we'll make sure we get to those answers. So without further delay, I'd like to welcome Dean Kraft with ISE Logik Industries. And I'm going to turn it over to Dean. You all received bios on him through your email, so I'm going to let him jump right into his presentation on specification strategies to eliminate concrete moisture.
Thanks, Lisa. Appreciate it. And good afternoon across Ohio. Would much rather be there in person. I always enjoy visiting up there, and I'm hoping a lot of you out there I've crossed paths with in the past, and please know I look forward to doing so in the future as well. Lisa already said you got my bio, but you know, a lot of you may know me already in this industry, at least from the ready-mix side, from the admixture side, because of the moisture vapor reduction admixture. I was the person that actually introduced it back in 2010 to the Ohio market. I used to live in Rochester. And in the past 12 years, I've actually presented probably more than 1,200 times. And things have evolved since some of you first met me. I'm going to talk about some ASTMs. I'm on the committee that writes the ASTMs. And, you know, this is really targeted towards the solving an issue for flooring, but since the concrete forms the substrate, the foundation for that flooring, I'm pretty sure a lot of you have gotten asked questions throughout the course of your career. You know, what's wrong with your concrete? Why won't your concrete dry? So as we go through this, that's going to touch on some of those and explain why you may have gone through that, and also some things that the project design team, which you would be a part of, can employ in a ways to address those issues. I'm going to take myself off of video just to save bandwidth, but obviously I'll still be here. And like Lisa said, you know, please feel free to fire away with questions, and I'll endeavor to stay on as long as possible after the presentation. So when we say specification strategies to eliminate concrete moisture, what we mean is literally from the entire discussion within the project team, post-concrete placement, pre-flooring installation, literally taking steps within the specification to eliminate that possibility of even a failed test from arising, from a project delay arising, from those pre-flooring installation meetings occurring, and you guys getting called well after the fact, asking what's wrong with your concrete. That's really the take that we're approaching this from, and in doing so, hopefully we'll address some things that you may have faced in your own careers. Now, besides my bio, which I won't belabor, but so I like people to know a little bit about me, and you guys got my whole bio, but I also like people to know, you know, the derivative source of a lot of the information that's going to be given. And I don't know how many out there that are involved with CSI, Construction Specification Institute, but if you're involved with CSI, or if you've ever done in their certification programs, really a lot of spec writers do that, then you may be familiar with some of these documents. But what I'm getting at is that a lot of this information comes from published information. It's not something we made up. Now, on the concrete side, many of you may recognize the bottom right document, ACI 302.2. That remains the guiding reference for designing slabs to receive moisture-sensitive flooring. Supposedly, it is under revision right now, but the 2006 version is still the most current. When I first got involved, I also often heard this thing called standard of care as it relates to design. And the best, being prior military, I was also ExxonMobil, Trex, Composite Wood Decking, and some other organizations. I was familiar with best practices. So the only way I could best for myself identify with standard of care was basically relate that to best practices. And so when I came across this cartoon, and I'm not even sure how I found it, when I read it, I didn't read best practices. In my mind, I read standard of care. And so the important thing about this particular cartoon strip was what I would like people to kind of ask themselves. Again, if you've ever gone through one of these situations with being asked, what's wrong with your concrete, or can you design out the moisture? Ask yourself why. Ask yourself why you're going through that process. Who came up, what industry derived that process of the need to pass a moisture test prior to installing flooring? It wasn't the structural engineers, it wasn't the architects, it was actually the flooring industry. And so once you grapple with that as we go through this, then ask if that process really is in the best interest of the end user, the client, etc. I'm not sure if anybody out there actually has AIA numbers, but if you do, please feel free to either send to Lisa or directly to myself, and I'll make sure you get the proper credit with AIA. We do self-report, so we can definitely take care of that for you. So again, if anybody out there has an AIA number that wants credit, please come to me directly or through Lisa, and we'll make sure that occurs. Otherwise, Ohio Concrete is doing a great job of taking care of their certificates. Okay. I got my doctorate. Another thing, if you haven't seen me in a while, I got my doctorate in business a couple of years ago, but my dissertation was on this subject. And when I present, if anybody's ever seen me present before, I move around a lot. I'm active. I ask a lot of questions. And one of the questions I've asked, just to kind of set the stage, to kind of get an idea of where people are as far as exposure. Has anybody ever had a project delayed due to concrete moisture? And I'm not talking, I mean, in relation to installing flooring, I'm not talking about actual floor failed and you got called back. I'm talking about brand new construction, moving along, you get a call, the moisture content's high, and everybody gets invited to those meetings at the project trailer to figure out what happened. Why is this occurring? And I will tell you that over the past 12 years, the response to that particular question is pretty darn high. But even if it's not, you've never incurred that, if you have projects that will have projects with concrete slabs, slabs that are going to be sleeve flooring, then hopefully then there's still some good information here to take away. Now, specification. So this title, Specification Strategies to Eliminate Concrete Moisture, seems pretty bold, throwing it out there. But before we go on, I really want to set the stage. What our frame of reference for a specification, and this is not to impugn anybody's intelligence. It's just, again, some really hardcore reminders of really what the specification is supposed to be. Now, if you get into the CSI literature, they'll describe a specification as the written embodiment of the work, the project. But one of the documents, a document specifically written for specifiers, describes it as the written communication of design intent to fulfill specific project requirements. So if you take that particular description of a specification, regardless of what it is you design, you can understand or wrap that definition around anything, whether it's civil, whether it's structural. You can still apply that to that design. Now, another perspective, getting into the actual project. And so now we're going to differentiate between a specification that is flat, lifeless, an office master, a third-party subscription service like a master spec or an RCAT or SpecLink, and nothing against any of those organizations, but when those specifications are residing on their system, or you have an office master and it's residing on your server, that's not really the specification we're talking about. We're talking about the project specification, a named project and a project manual. And the reason why we differentiate is because in many cases, once that flat, lifeless spec goes from the server to a project, it takes on legal ramifications. It becomes part of the contract between the owner and the contractor. And one of the often used documents under general conditions, specifically for structures, is the AIA 201 general conditions. And in that document, it clearly states that the architect and their consultants, perhaps a lot of you out there, shall be deemed the author of the specification. So put another way, what that's saying is it does not matter where the source came from for a particular specification. It does not matter. For that project, the architect and their consultants wrote it. So just keep that in mind from a legal perspective. The way something becomes a contractual obligation for a specification, it doesn't matter if it's a copy and paste. It doesn't matter if it, how it got in there. For that document, for that project, the architect and the consultants wrote it. And because of that, there's some legal safety net implicit due to the Spear doctrine going back almost 100 years that accrues to the contractor. And that is the contractor has the absolute right to be able to expect that the specs are accurate and complete, that if they perform the work as written and drawn in the drawings, then what they deliver will fulfill what the owner wants. And if there's something missing, if there's something that wasn't planned for, then the contractor really can't be held accountable for errors, omissions, cost overruns, project delays. So just keep that in mind. The specification drives that, not necessarily actions, all the actions on the job site. Okay, so what drives all this? Well, in the beginning, somebody decides to build something. A client decides to build something, renovate something, repurpose something, build something from the ground up. They come to a design team. The design team needs the structure, and so somebody conceives of a project, and it's in the process of specifications. It's that early on that the design intent is supposed to be conveyed. It's supposed to be expressed in those specific project requirements. And again, from the concrete world, a lot of things are designed in a silo where you have the O3 specification section done possibly in an offsite consulting engineer, and then at some point in the future, they get married up with the other spec sections of the project. But that is, that's irrespective. The whole design intent and the requirement for the owner, they don't see it that way. They see it as a seamless process. And so if something's missing across any of those sections, or if something's not spelled out, then it could lead to unfulfilled expectations. And the better those requirements are understood, i.e. time, delivery, expectations for the project schedule, the higher probability that the owner is going to be satisfied, that the project is going to fulfill what they expect. It's going to be a success. And if something is not covered, if something is not effectively addressed, the higher probability that those requirements will not be fulfilled. And it's not just enough for the contractor to build according to the project manual. That's pretty much defined as quote unquote all claims resolved. But the literature for projects tells us that it's not just enough for the project for the contractor to do all that, but they also must do it on time and within budget. And that if any one of those three things are not satisfied, then by definition it is an unsuccessful project. So the completeness and accuracy of the specs is critical to be able to fulfill those three things, because not only does it affect whether or not the resulting end product is actually what the owner wanted, but the specifications of drawing are also used for bidding. And if they're incomplete, there's a good chance that something may be missed, something may not be taken accounting for, leading to maybe future change orders and cost, or extra time in the contract. So again, accuracy and completeness are critical for overall success of the project. Now, just bear with me now, because again, I've got to try to marry the concrete side with the flooring side. And here's some examples of how things start getting skewed once a lot of you have done your work and left the project. First of all, as a reminder, the architect and their consultants, they are the author of the spec. the other thing about the spec language reminds design team members, project design team members is that just because a material is inexpensive doesn't mean that being able to incorporate it into a project is also inexpensive. You know, as an example, there are many different kinds of flooring systems that are fairly low cost for installation and also acquisition. But when it comes time to install, if there's a high moisture test, then you have to go to moisture mitigation. That cost for flooring may double, triple, or quadruple. That's why you get called to those meetings, because that project is staring down the face of a very, very expensive topical moisture mitigation system or project delays. Another thing the literature tells us is beware of bias that might be embedded in manufacturer specs. Now, regardless of what you specify, this pertains to all manufacturers. Obviously, you know, that relate to flooring as well. But it's a reminder that beware of bias. Actually read the wording and ask yourself, is this really a requirement? Or is this a means for that particular manufacturer to try to drive another value line through a component? In flooring, it might be, you know, that manufacturer requires their adhesives to be used. Well, is that really a requirement? Because there's only a few manufacturers of adhesives on the flooring side, most of them private label for all the large manufacturers. Or is that just an attempt by that manufacturer to sell another SKU? So just keep that in mind. There may be embedded bias and that you must be aware of, take into account as you look at specs, especially if you get it straight from a manufacturer or a third-party subscription. Now, this does have pertinence to basically every single spec section. And the literature of the specifications say that reference standards are incorporated as if they were written in their entirety into the spec. So keep that in mind. I know, especially on the concrete side, there's a lot of references, and a lot of them have to be there. But just keep in mind that a reference standard incorporated has the same legal effect as if it was copy and pasted in its entirety. So if things start going down the path of during a project and questions start being asked, you know, things like install per manufacturer's instructions, if those instructions weren't fully looked at prior to moving down the project, don't be surprised if something manifests down the road that people didn't expect. And then lastly, installation methods. Again, more slated to flooring, but it does relate back to the concrete side. And what the specification literature says is, if your project has conditions that do not meet the manufacturer's requirements, change the installation instructions. And as an example, if the concrete moisture is reading too high, what the literature for the spec writer says is we'll change the installation instructions. And so all we're trying to do is step back and to take these things into consideration well up front in design, so these things don't occur too late in the project on the back end. Now, again, if you've ever been called to one of these meetings before, or if you've ever heard presentations before, or been associated before, or been involved with projects before, you may have been faced with this comment. You know, we can't install a floor because we can't get the warranties. So again, this is just a minor question to ask people, but again, this has been highly, this is probably one of the most prevalent comments I've heard in the past 12 years. Well, you know, if the concrete moisture is too high, you know, we can't get warranties. So I'm going to address that. Now, why is this such a big deal? Why should you guys care? A lot of you guys and gals care, you know, for the flooring schedule. Well, this is why. This is where it becomes a train wreck possibly for some projects. Obviously, a lot of your work, specifically for the slabs, happens fairly early on. So if you envision yourself sitting there, or, you know, behind this young lady looking at her computer screen, the concrete happened most likely fairly up and to the left, sometimes months and months and months in advance of flooring. A lot of you are already gone away from the project. Your work is done and it's well behind you. But at some point in the future, sometimes way far in the future, way down far to the right, somebody's going to come along and drill a hole in that concrete and drop a probe. And so you may have been gone from that project 6, 8 months, and then you get a call. Why is your moisture so high in your concrete? And you're like, what project is this? Well, the reason being is now the press is on because flooring isn't just its own sub-element that does not impact other elements. It is its own element as far as the macro critical path for installing flooring. So a high moisture test can delay one of those little blue lines. But flooring in the overall schedule happens very, very close to substantial completion. And in fact, in some cases, it's one of the last or near last things that occur because the project just don't want all the other trades walking in and trashing the floor. So if that flooring is delayed and it's close to substantial completion, not only does it delay the flooring install, but it can also delay the overall project delivery. I know of a project that the flooring was delayed in the northern part of Cleveland for over 5 months. The university did not have the moisture mitigation money. They decided to wait and retest. 5-month delay, which equates to potentially almost losing that facility for 2 semesters. So just think about the cost of that. Again, think of yourself, if you've ever been asked to one of those meetings and they say, when you're being told, you're sitting there, or people from your organization are sitting there, and you're hearing, the project manager or the owner's rep saying, we expected to start flooring 3 months ago, and this moisture is still too high. That's why it's so critical. That's why it's so critical, really, to think about this in the specification, in project conception, not right before flooring. Now it's too late. Okay, so I mentioned some references. What kind of references are we talking about? Well, on the flooring side, there's a lot of references that come into play. Basically, every manufacturer of flooring has their own reference. There's ASTMs out there. And a lot of these are written by consensus bodies. Now, granted, again, a lot of you have done your work and moved on, but now this is what's starting to play out with you not being there. And what people don't realize is a lot of these organizations are made up by the same manufacturers. So it's the flooring industry that came up with the idea that you have to test for moisture prior to installing flooring. It's the flooring industry that sends people to these various organizations. I mentioned I'm on the ASTM for flooring, and that's ASTM F6 committee. And that's like 156 people, most all from moisture flooring manufacturers, adhesive manufacturers, moisture mitigation manufacturers. So in other words, they write their own standards. They write their own resources. Just like if you go to ACI, there's a lot of concrete and engineering people, as it should be. But again, keep this in perspective. The flooring industry was the one that came up with the need to moisture test prior to installing flooring, not the concrete world. The flooring world came up with that. And the flooring world writes the references and the ASTMs they hold themselves accountable to. But despite all that, and despite those being consensus documents, in most cases, the individual manufacturer's literature actually is the one that takes precedence. And so, regardless of what kind of building you may be involved with building, if they're installing flooring, there's probably something moisture sensitive. So I don't care if it's a gymnasium, it could be outdoor tracks. It could be outdoor tracks. I just got a call 2 days ago from a large national installer of indoor, outdoor tracks, sports facilities, and they have certain materials they install, even outdoors, that have moisture limits. This also pertains, by the way, to concrete roof decks. So it's not just flooring. This whole discussion applies to basically, if somebody's going to try to put a coating on top of your concrete, then this discussion applies. So what test are we talking about? And so this is where especially the engineering minds out there, the process folks out there, start really paying attention now. Okay, one of the things I was talking about when there was a little bit of difficulty there is that the references, at least from manufacturers, are basically written by the same manufacturers. In other words, they are they go to the committee meetings, not so like ACI, but just keep that in mind. So that standard of care for testing for moisture derives from the flooring industry, not from the concrete industry. The quote unquote standard of care for setting a certain limit also comes from that industry. and sets those requirements. So again, keep that in mind, that when you get asked questions about why your concrete can't perform to something, the concrete industry didn't come up with that. The flooring industry came up with that. And pretty much all flooring is susceptible to some moisture limit. So basically, if your feet touch it, it's not bare naked concrete, then there's probably a moisture limit. So the moisture tests you've probably been in meetings or heard about are the calcium chloride or the in situ probe test, the 2170 RH test. The most often used is the relative humidity test. And one of the first things, especially for the engineering mind, the process mind, is to grapple with and understand is that the size of these tests and what the standard actually says. Again, you're not going to find these standards in the 03 spec. These standards, the flooring industry have gotten into the 09 spec. So retroactively, after all your efforts are done, then they have come up a way to go back and then test your product. And these are the tests. And this is what the standards say. The standards say that 3 for the first 1,000 square feet, 1 per 1,000 square feet after that. It doesn't tell you what is the first 1,000 square feet. It just says 3 for the first 1,000 square feet. So let's make the math easier and say 1 per 1,000 square feet. Now let's talk about the size of these devices. The one on the left is about a 20-inch by 20-inch square. So envision, look down at the ground and envision one of these on the floor where you are. Now imagine you're at 1,000 square foot space. One of those 20-inch by 20-inch square per 1,000 square feet. The one on the right is is about the size of a quarter, diameter of a quarter. And again, 1 per 1,000 square foot. So just take a quarter out of your pocket, if you have coins, and put it down on the ground and say, okay, that's where the test goes. Now, not only is that something that's codified into the ASTM of the area, the size of these devices, but this is what the standard says that is supposed to be the climatization. When these tests are occurring, and I know this does not occur in most cases, so just be aware, if you go to a job site and they're doing these moisture tests and it's not acclimatized, then those results are invalid. Whoever's doing those tests are doing them wrong. And I'm pretty sure you've been called to job sites or you've been involved with projects where you know for a fact that the space is not acclimatized, but they're already doing moisture tests. Those results are invalid. The standard says must be at the conditions of occupancy beginning at least 48 hours prior to the test through the conduct of the test. This is not torpedoes blowing in heat, elevating the humidity. This is controlling the HVAC. This is controlling the humidity and the temperature. Also the substrate temperature. So especially now we're in colder weather, if you're on the second or third floor and they're testing for moisture, even if that space is acclimatized, but the space below is not, measure the temperature of the concrete. The temperature of the concrete is also supposed to be at occupancy conditions, not much colder, which is usually the case. Now, why did I go so much time on the size of the device itself? Because the standard says that not only are you only testing the exact time of the test, so that instant point in time, but also you're only testing the exact location. So all that's being tested, that per 1,000 square feet, is that less than the diameter of a quarter, that 20-inch by 20-inch square. So as we think this through, and we think about how this relates to flooring and adhesion warranties and moisture warranties, all you're testing in most cases is less than the diameter of a quarter. Now, big misconception across a lot of attendees to the presentation. I've been asked this many times. Anecdotes or vignettes, people say like, well, we place concrete in the summer, had a dry winter, the fall was a little wet, then we started trying to get the building closed in, some rain, snow, whatever, finally got it closed in, temp heat, got it watertight in March, April, got the HVAC running, started testing in June, and the moisture content was off the charts in the 98% range. What's wrong with the concrete? Because a lot of people have been led to believe that the date of placement is a primary driver for being able to pass these tests. Some people have gotten in their mind that, well, 30 days per inch thickness of concrete and the concrete's dry. Well, the literature does not say that. It's actually never said that. And in fact, the guiding document for slabs to receive moisture flooring actually talks about the last wetting having the greater impact even over the initial water cement ratio. So efforts to try to engineer out the water, getting down to a 4.2 or a 4.1 or 4.0 for an interior slab, really is not conducive to passing a moisture test, because it does not alleviate, does not mitigate that last wetting. What is the last wetting? Well, ACI is very clear. Waterproof roof and walls not present when the construction of the concrete slab occurs. What could be a wetting? Well, a wetting could be rain, sleet, snow, burst pipe, wash down. It could be high humidity due to the torpedoes. It could be dew point. Most projects go through dew point or frost point cycles every single day, and they don't even realize it because it occurs either so early or so quickly. All of that keeps the moisture in the concrete, keeps that moisture content high as far as the humidity probes go. So just keep that in mind. Also, too, the same document, ACI 302.2, states that not only is the last wetting that drives the moisture test results, but there's another last wetting that most people aren't even giving any consideration whatsoever, and that's the adhesive itself. So even if you were able to deliver this bone dry concrete slab, the same document, ACI 302.2, talks about the residual moisture in the adhesives themselves having enough liquid to induce residual alkalis, unreacted alkalis, to go into solution and to create a change in pH. Well, if there's enough moisture to create a residual pH solution, what is that doing then to the humidity of the concrete? It's elevating it. Same thing with self-leveling underlayments. So again, from a process mind, how does testing for moisture and then slathering it with a liquid have any correlation whatsoever to future adhesion? This is also from an ACI magazine. ACI, it was Concrete International, so go back to, it was a longitudinal test done concurrently. 2011, they placed some slabs down in Dalton, Georgia, ran for 13 months. After 13 months in a warehouse, not acclimatized, the test didn't pass the limits for the flooring. Ran concurrently in an acclimatized space, 7 straight months, didn't pass. And that's the conclusion right there. This conclusion right here is what designers in schematic design need to keep at the forefront in thinking about concrete moisture leading for flooring. If your project does not have this, don't expect to pass the moisture test. Otherwise, don't be surprised if you go through this over and over and over again. Now, ACI 302.2 also states, and has stated for going on 15 years, that there actually is no relationship between the RH of the concrete and the adhesion of resilient flooring. This is not me writing this. This has been in there for 15 years, and it's not just solely related to the RH test. It's also related to the calcium chloride. So basically, if you get called to these meetings, you're being asked why your concrete can't meet a threshold limit imposed by the flooring industry for an issue that has no relationship to the adhesion of their flooring products. Again, that's been in there for 15 years now. Warranty. Then you hear, well, we got to do for warranties. Well, a simple look at flooring manufacturer's warranty clearly points out that moisture is not covered. Even if you meet those moisture tests, any issues that evolve after the fact due to moisture are not covered. This is just a sampling of 4 different warranties across the flooring industry. Now, I mentioned before about installer manufacturer's instructions. So what could occur if, once you guys have done your work and ladies have moved on, what could occur based on other spec language? 2 quick scenarios based on what could happen just from 4 simple words: install per manufacturer's instructions. This is a very, very popular flooring product for healthcare. It's a rubber flooring. So if the flooring spec says install per manufacturer's instructions, this is going to be set in motion. And this is kind of standard. Test per RH test, which remember has no relationship to flooring. Very low limit. If it doesn't pass, wait or remediate using a two-part epoxy. These could be $5, $6, $7, $8 a square foot. So if you're wondering why you're getting called, is because somebody's looking to put $5, $6, $7 a square foot on top of that concrete, by the way, well in excess of the cost of the entire slab per square foot, just to be able to put the flooring down. That's why you're being called in there, because they're staring down a significant change order in money and time. The way the language is written, it's actually the flooring installer who makes the determination if there's an issue. And then the flooring industry even goes so far as to tell the project what they cannot do. But remember, this is manufacturer's literature. The only way it gets into the spec is if the architect or their consultants put install per manufacturer's instructions or use these guide specs that have this language embedded. This same manufacturer does not warrant for moisture. And in fact, anything to do with excess moisture is specifically excluded, irrespective of the fact that they've already told them that how to test, who decides, what test, what you can do and what you can't do. It's not limited to that one manufacturer. This is a resilient sheet used in health, also used in healthcare, institutional, schools. That's the kind of flooring product you see. Think linoleum. Great product, not very expensive product in the whole spectrum of flooring. But the language of their spec, again, requires moisture tests that most likely the concrete cannot pass. And if it doesn't, it requires a moisture mitigation, most likely a two-part epoxy. So if you wonder why this gets emotional and why you keep called in, it's not because your concrete's performing bad. It's because that project is now delayed and staring down a significant change order in cost and time. All for an issue that's not covered by warranty, all for an issue that's not even related to adhesion. And then lastly, about ASTMs and about these standards. Just recently, and this does kind of go back to you, the guiding document for designing slabs to receive resilient flooring, other than the ACI document I was talking about, is ASTM F710. And that is a standard practice for preparing a concrete slab to receive resilient flooring. That's the document that requires moisture testing on all slabs. It was first published in 1998, and in 2017, a new paragraph was added. And that new paragraph puts it on the design team, which many of you would be involved with. It makes it their responsibility to determine if a sub-slab vapor retarder was present, installed correctly, is it still intact? And then also it's design team's responsibility to take the moisture test results, determine if there's an issue, and then the design team determines how to address. Well, people could say easily, well, that conflicts. Remember I said about references maybe being a conflict. What's actually in these references? What do they say? People could, you can easily say that, well, that conflicts what you just told us about what these manufacturers say. No, because what the standard also says is that nothing in this standard shall supersede in any manner the manufacturer's instructions. So this document is also written by the manufacturers. So even though they put this on the design team, they still reserve the right to themselves by this paragraph right here. So to make no mistake, it always stays with the flooring industry with this particular process. So what do you do? Well, again, install per manufacturer's instructions obviously will be in the 09, but again, think about the 03 spec. If the 03 spec does not take steps to head this off, then don't be surprised if you get called into it, because that's the way the process has evolved over the past 20 years. All for an issue driven by the flooring industry. A moisture limit that most likely concrete cannot pass. And by the way, concrete being at 100% humidity is not bad for the concrete. For an issue that's not even related to adhesion, and for an issue they don't warrant. So the specification strategies that we specifically, try to drive into, across various specifications is one, everybody's worried about the warranties. And so this first recommendation really goes to the warranties. granted, this is out of your bailiwick, but still, it's part of the project. It's something to keep in mind. And one of the things the project team, design team can do is simply require the warranties to convey. This language right here is from an architect in Cleveland area, as it happens. They've used our admix before, and to make sure there was no question about whether or not warranties were going to convey, they just put it in the 01 portion of the specifications of the 09 products and said, yeah, manufacturing defect warranty shall convey, and we don't expect moisture to be included. They didn't stop there. Again, they put our product in the 03, but in the 09, then they also required the warranties for installation, quality manufacturing, and workmanship. Again, moisture not included. So there are ways, because remember, the architect and their consultants, you and them, are the authors of the spec. You decide what goes in the language, not a manufacturer, not me, not in a different industry. You guys and gals decide what goes in the specification language. So that's one way right there that the issue of whether or not a warranty is going to convey is taken off discussion. Now, the liability for concrete moisture. This is one of the things that could be done in the 03 section. And one of those ways is just to simply start off with specifying an approach that is warranted to 100%. For interior slabs, all interior slabs, all day slabs, anything to receive flooring or roof decks, put something in that's already warranted 100%. If somebody else takes it out, that's their choice. But this is one of the ways to absolutely head off the entire discussion of whether or not moisture testing is even required or how the project is going to address it. Absolutely, absolutely in the purview of the design team, not a manufacturer. And if this is incorporated at the exact same time with that other language I said about the warranties having to convey from the flooring side, then the project team's liability for moisture and the warranties is now covered, and the owner is going to get what they expect. This one right here, this one kind of goes back to, and this would have applications, I think, as well to any product you might specify. It just be careful with some of the language, or be aware with some of the language. Is some of the language really, really necessary? You know, is it necessary to have use an adhesive as recommended by a manufacturer? Or is it better a more open language to say something more like, you know, suitable for substrate conditions and compatible with flooring backing, or for whatever product you're doing? Just keep in mind that changing the installation instructions does not necessarily mean some total rewrite. Sometimes it's just tweaking it to open it up a little bit for other products, as opposed to saying or equal. Because really, as everybody knows, that if a branded product's listed or equal, the default is going to be the branded product. Most people are not going to follow the or equal. That's just the way it's going to work in the bidding process. But if you have language like this and something changes, some new information comes out once the spec has been published, this allows a little bit of an audible to occur. So keep that in mind. And then lastly, this is also some things we're seeing now too, where projects are elevating this even higher into the summary of work, division 1 spec section. And here's the case where the admixture was used. And as you can see, they're saying, hey, this product is going to be used. This is what it does. All subsequent flooring contractors bid accordingly. Again, the architect and their consultants wrote this, not a manufacturer. Then they say, if flooring contractor, if you think some kind of remediation to get your flooring systems to bond to this kind of concrete, sure, you can do it at your expense. And by the way, the owner is not paying for moisture testing, and we're not changing out the adhesive. If it's going to be a direct glue down, we're not going to accept a double-sided tape. We're not going to accept something different. So make sure you do your due diligence. Here's just some examples of how projects have grappled with this up front in the document phase, so that when it gets time to install flooring, people like you aren't ever called back because you're long gone and your work is done. And it's not unusual now for during pre-slabs, if the admixture is used, that flooring installation is now often discussed. So just think about that at a pre-slab meeting, possibly having a flooring contractor there. We've done that several times now, and it's very, very effective, assuming the flooring contractor is known at that point. Well, that ends the AIA presentation. Sorry about the technical difficulty, and I hope everybody is still there. But Lisa, I've got about 5 more minutes for my product, but if there's any questions right now, I'd be more than happy to take them.
Yes, we do have a question. What is your opinion on in situ moisture probes?
Two questions. And if whoever asked that, if they would reiterate, there's 2 uses. One is they're often being used also temperature probes for the maturity of the concrete. And I've been to trade shows, I've talked to those people, and I think that seems, very, very interesting. And a lot of times they have an in situ probe as well. As far as for moisture and concrete as being anyhow related to whether the floor is going to fail or not, it's not my opinion. The plain language of the documents going back 15 years is there's no relationship. They have no correlation. And when you're testing the size of a quarter per 1,000 square feet, if you really look closely at what these documents say, the flooring manufacturer's warranties say they don't warrant excessive moisture. Well, the only way that language would be pertinent at all is if that flooring failure occurred right on top of the probe itself. It's important, really, especially for the engineering mindset, to dig down into the sensor. Most of them are Sensorion sensors from Switzerland. A good product, a good manufacturer, but it clearly states in their hysteresis data, if that sensor remains in a high humidity environment for a fairly short amount of time, it will drift. It will drift up and basically peg out and not come back down. So the idea that you're going to drill holes and leave these probes in for a long period of time is a fallacy, and it's not how they're designed to be used. So as far as my dissertation title, just so you know, was "The Fallacy of the Flooring Industry's Approach to Assessing Concrete Slab Moisture Prior to Installing Flooring." One of the big reasons why was what the probe does and does not do, and what is warranted and is not warranted. For this particular discussion, and supported by ACI 302.2, the RH of the concrete, even if measured absolutely accurately, has no relationship to whether the floor is going to adhere or not, has no relationship to a warranty for moisture. So regardless of whether it's accurate or not, it's not relevant to the discussion. So then why do it? That's why we say just go ahead and specify something that's already warranted 100%, so you can literally skip over that step. If you're talking about probes in the mix for the maturity of the concrete, everything I've read on them and talked about, they seem pretty very, very interesting based on temperature. But as far as embedded in the mix for long-term study of the RH for flooring, no, the drift of the RH is not it's gonna blow that sensor out for RH for long-term. So I don't know if that answers your question. I hope it does. But I just remind you what the literature says from, your industry's guiding organization, ACI. No relationship. And by the way, there was a moisture task force on that committee that wrote that language. So it wasn't just a bunch of concrete people came up with that. There was a moisture task force.
Dean, we have another question. In your opinion, are vapor retarders mandatory even with a moisture admixture?
Excellent question. In my 12 years, I've been involved, obviously several issues, and the most egregious issues, probably 4 in 12 years, all were related to sub-slab vapor retarder either not being present or misplaced. And here's why. Obviously, everybody on this concrete knows concrete does two things: gets hard and cracks. And so sometimes it cracks where you want it to, your control joints, or you have your expansion joints. And then sometimes it cracks where it decides to crack. So good quality concrete, let's say it did not crack, and you just have your joints, your expansion and control joints. If the flooring contractor, big if the flooring contractor properly addresses, cleans out, routes out, fills those cracks to rejection with polyurea, or honors the expansion joint all the way up to the flooring and doesn't cover the expansion joint, which most flooring you're not supposed to cover an expansion joint, then there's a good chance you would not need it. However, 30,000 square foot corporate aircraft hangar in Richmond, Virginia, gorgeous epoxy flooring, very expensive flooring, put over the entire floor, no joints in the flooring itself. And so when the concrete started moving, there was the vapor retarder was 6 mil poly, it degraded, it was almost all gone. When you walked into that hangar, you had bubbling floor almost every 10 or 15 feet in a straight line across the hangar. Why? Because that's exactly where the joint was. Another spectacular failure occurred in a 2-story hospital addition out in Oklahoma. Slab on ground, elevated slab, both had the exact same normal weight mix design, placed in really, really hot weather. I mean, the silos, the concrete, the aggregate was over 100 degrees. Really, really hot days, really, really hot mix. And for whatever reason, they put the plastic down and they put like 2-inch rock on top of it, because that's quote unquote, that's the way they do it out here. And that rock sitting in the sun got hot. I mean, super hot. And so the concrete subcontractor, there's pictures of them with a hose watering that rock down to cool it so the bottom of the mix didn't flash set. And so they're placing the concrete, they placed the elevated slab, fairly fast track. Within a couple months, the building's closed up, flooring goes down. Same flooring, same mix, same everything when the concrete was designed or placed as far as temperature. The slab on ground flooring was almost 100% total failure. The elevated slab had no issues. Why? The plastic acted as a reservoir, the hot rock. They basically placed concrete on a steam bath. The heat, ACI 305 was not followed correctly. The concrete microfractured. And so the slab on ground flooring blew off 100%. I actually told Skanska national headquarters, North America in Blue Bell, Pennsylvania, they asked me that exact same question. 100%. If we use your product, do we have to do vapor retarder? And I said, I wish I could tell you no, but if you got money for one, do the vapor retarder first, because you got one chance to put it down. Now there is some relief on the vapor retarder cost. The standard is no longer 10 mil. The standard is no longer, it was never 15 mil. The standard is just to be compliant with ASTM E1745. There are some 6 mil products out there, but it really has to, it depends on the tensile strength, the permeability, puncture resistance, things like that. So you might be able to save some money to get a less thicker product. But yeah, that's one of the requirements. Now, if your slab does not have one, there are products you can put on top that won't require moisture vapor retarder or vapor retarder. But there is a product, I will tell you this, there is a product in our category that tells you that you can leave it out. That's not something I would do. I would literally advise the project to, if they had money for one, vapor retarder first, and we would lose the sale if that was what it came down to. So yeah, the vapor retarder is pretty important. And it's not for, what it is it's for ground moisture. Your concrete, below your concrete slab, it's going to go to 100% RH. And if there's any imperfections of any kind of size, then it's going to go through, specifically in any kind of cracking or properly addressed joints. The problem is that's where the division of the silos of the specs come from. You guys and gals could specify a fantastic concrete slab, which I'm sure you do, and your producers in Ohio deliver a fantastic slab, which I'm sure they do, and the concrete subcontractors there do fantastic work, and you're all gone, and the flooring contractor just not address the joints correctly and have a failure, and then everybody gets invited back to the party. That's really what the problem is. So without the vapor retarder, the project is really exposed to the quality and workmanship of the installation of the flooring, and then having to go through forensically and determine if it was the install of the flooring that didn't address the cracks correctly, or was it moisture from the ground. So yeah, it's pretty important.
Dean, we have a couple other questions. What
Sure.
adhesives or products have you seen that warranty 100%? This info is a critical piece.
Well, it's funny you asked that. I will continue to, because it's funny, we have one of those. For the admixture, people know about it. So I'm going to answer that question as I go through the last couple of slides here. Our product is called MVI 900. That's the admixture. Now, I know you guys know Barrier One. I know you guys have heard that product name before. What differentiates us? Well, we're all an admixture. We're both warranted 100%. But what differentiates us between any other product in the admixture category is two things. First of all, we fully disclose everything on our product. Secondly, the largest manufacturer of flooring adhesives in the United States is Taylor Adhesives. We are the only product in our category that is not only cross-warranted by, but is also recommended by Taylor Adhesives. And that is critical when it comes time for flooring. That is critical at a pre-slab meeting when the project manager can actually call Taylor and tell the flooring guy, hey, listen, I can already talk to Taylor, and we've already got adhesives if your manufacturer has an issue. Very, very critical. Now, obviously not all products receive the admix. This is a 100% adhesive, warranted 100%, does not require a vapor retarder. Can be used for any kind of resilient flooring. What does that mean? All of these kinds of flooring right here. Not only is there this adhesive for all kinds of resilient flooring, there's also a separate adhesive for wood flooring. So to go back to answer the question that was just asked, there are absolutely adhesives out there right now, several different manufacturers, been out for a while, that do warrant to 100%, are themselves moisture vapor barriers and waterproof. What does that mean? So let's say you have a laminate floor and say that the person that's cleaning really super saturates the surface and it drips down in between the cracks. The flooring adhesive is not going to degrade. The flooring itself may swell, but the adhesive itself is not going to degrade. So this is one of the options that would answer your question. Absolutely available in the market. Certain manufacturers are going this way, but let me be clear on adhesives. Some projects, their approach is, we're going to test for moisture and just pick a higher RH glue. In other words, the concrete's 95, so we're going to pick a 98% glue. That is a red herring. When a glue says it's good to 98% or 99%, what it's saying is that glue itself can exist at 99%. It's not saying that it blocks 99%. So if you have flooring backing that's only rated to 90% and your concrete's 95, that 99% adhesive will be fine, but it doesn't mean the flooring backing won't degrade. It's got to be a moisture blocker itself, a moisture barrier. And so this is one of those glues right here. And they also, so that covers that. And we also have a one-part topical that's probably $2 a square foot cheaper than the two-part epoxies. I won't belabor this one right here, but what I'm getting at is that there are a lot of options across the spectrum that projects can do. And this example right here, what is the cost benefit analysis? This product was used by Boise State. They are going to use a two-part epoxy 30,000 square foot. And this saved them a week in construction, and it saved them about $60,000, about $2 a square foot. So, you know, the ad mix, you know, we're involved with a really big project right there in Columbus, a very, very large hospital complex, and great ready mix producer, great project team. And on project that size, it's not unusual for the inclusion of the ad mix to actually save months off the construction process. And what I'm meaning is that when you start that project with 100% specification to address concrete moisture, remember that's the document phase. Okay, you know, that's before bidding. So when the contractor gets the GC gets all the way forward at some point, 18, 20 months in the 4 months in the future on a large project or a school project, 12, 14 months in the future, and they're staring down, you know, they got to start flooring because they got to meet that opening date. Everything I just talked about is gone. The GC goes, climatize the space, flooring sub, install your floor. That's the process. So everything I just talked about is eliminated. And you can do so by, at least proactively for the concrete, having the ad mix for all interior slabs and roof deck. And then obviously just being aware that if you're doing any kind of building, it's likely to have flooring. So just keep this in mind. If you don't watch out for your interest, that flooring spec is going to keep drawing you back in. This is why, because moisture testing is embedded and it circles back to your product, which again, the literature clearly states there's no warranty and even no correlation, but you can head that off with some very simple direct strategies. So
Dean, we have one last question.
Go ahead. Perfect.
Nano-silica technology is being promoted as an internal cure for concrete design to hold on to water molecules. Does this type of technology adversely affect moisture drying a slab?
Well, nanosilica is, you know, what they're doing is they're consuming additional calcium silicon hydrate because that's really that's what they're really going for when they use nanosilica. But the internal cure is, yeah, it's going to keep moisture in the concrete. But I said earlier that that's great for the concrete. You're going to have less dimensional change. You're going to have more even strength gain, probably higher breaks. Yeah, it would give you a higher moisture content or higher RH test. But if that nanosilica product was warranted, and I know one product out of Indiana that kind of goes after that, Element 5 goes after kind of the internal cure kind of aspect. But if it's not warranted for moisture, yes, it could delay achieving a certain moisture limit. And from my perspective, just remember, everybody knows concrete. Mother Nature is the biggest demon when it comes to, you know, when and how to cure. It's one of the ones that people often forget. A slight change in temperature or wind or solar radiation can greatly affect when and how the curing process should begin. And a lot of people forget that, or a lot of project teams forget that, and leads to problems. But yes, by the mere nature of them holding moisture in, you know, internal curing, if we're only speaking about passing a field moisture test, then yes, they would further delay passing that test. If that product was also warranted to 100% RH for flooring, then the issue would be of no concern.
Well, thank you, Dean, for taking time to give an outstanding presentation to our group. I really appreciate it.
Well, my pleasure, Lisa. My pleasure, Lisa. And like I said, I love Ohio, and always enjoyed all the people up there. And so just wish this was in person, and wish we were in a big room and go have a beer or two right now.
Yeah, I'm sure everybody on the line feels the same, including myself. So thank you very much. And we did record this presentation. It'll be available on our website if you want to view it again. We do apologize again for the technical difficulties on behalf of Ohio Concrete, and do our best to make sure that doesn't happen again. We're going to have our last webinar of our series coming next Tuesday on December 15th at 1:30, and this is our ethics credit seminar. John Greenhalgh is the executive director of the State Board of Registration for Professional Engineering and Surveyors. And he will talk about common violations of the Registration Act and how to avoid them. So hopefully we'll see you here next Tuesday. And thanks again for taking part in our seminars. We greatly appreciate it.
Yes, thank you very much, everybody.
Thanks, Dean.